Hello, Math 157ers. We're going to talk today about the last section of 8.3, hypothesis testing in 4 steps. Just checking my audio. And let's get through it. I'm going to focus especially on using StatCrunch with 8.3 and also do one of your assigned homework problems with you. All right, there are 4 main steps in hypothesis testing. State your hypothesis around the population parameter. Choose a significance level, test statistic, check the requirements, and state the assumptions. Compute to compare. So we're going to compute the test statistic and find the p-value to measure the surprise. And we're going to interpret it. Reject or fail to reject the null hypothesis. And we're going to state the conclusions in the context of the study. Here, we are only, our test statistic is the Z statistic. We will use StatCrunch to calculate it for us, but when dealing with proportions, which is really what Chapter 8 is about, Introduction to Hypothesis Testing with Proportions, we are using the Z statistic. All right, so let's talk through this example. Each year, 5% of the world tiger population is killed by poachers. Now there's a campaign to educate people on this problem. So has this percentage gone down? So we know that right now 5% of the world's population is killed by poachers. And now we have over 300 tigers and 18 were killed by poachers. So our H0, what we accept, what we know to be true, is P is equal to 0.05. And again, remember here that the H0, the hypothesis, is always a statement of equality. So you may see in your homework, well, they will write something like H0 P is not equal to, P is greater than. You can cross those off right away because H0 is always a statement of equality. HA is that P is less than 0.05. It's what we're hoping. We're educating people and we're making that the number of tigers that are being killed by poachers, we're hoping that percentage has gone down. All right, so that's our first example, and we'll come back to that. Second example, 90% of all restaurants fail after a year. The question is that number different for Chinese restaurants? So they're talking about difference here. They're not saying necessarily do less Chinese restaurants fail. They're just saying, is it the failure rate for Chinese restaurants different from this 90%? Of the 108 new Chinese restaurants, 87 had failed after a year. Okay, so our H0 is that the proportion is equal to 90%, and the alternative is that P is not equal to 90%. Let's go through step 2, back to our first example. We've got our hypothesis. We're going to use the standard alpha equals 0.05, and you always have to check in that your n times your p0 has to be greater than 10, and your n times 1 minus p0 also has to be greater than 10. And really, the world population of tigers should be more than 3,000 tigers. So remember, we had that little test of n times that it has to be less than 10 times the it has to be less than 10 times the population. Is that right? Yes. We can use the Z statistics. Okay. So there are more, and this is what I said not very eloquently. Assume that the 300 tigers were randomly selected, and there are definitely more than 3,000 tigers in the world. All right, so I don't like how they jump around a little bit, but really in terms of our preparation, we are going to choose our level of significance. We're going to test to make sure that we can use this, and we're going to go through all the steps. So again here, 90% of all restaurants fail after 1 year. The number different for Chinese restaurants. Use the standard alpha equals 0.05. We do n times p0, make sure that that is equal to a number greater than 10, which is, and then n times 1 times p0 is also greater than 10. We can use the z because we use the z when we're dealing with proportions. Okay, so we have 108 Chinese restaurants, and we are pretty sure there are more than 1,080 Chinese restaurants in existence. So now let's go back to our tigers. Each year, 5% of the world's tiger population is killed by poachers. We have our educational campaign, and here is our output from StatCrunch. So H0 P is equal to 0.05, and our alternative is that P is less than 0.05. Okay, how do we get into that in StatCrunch? Stat proportions, one sample with summary. Number of successes, 18 out of 300. P is equal to 0.5. And remember, we're testing to see if the percentage has gone down. Less than 0.5. Compute. And let's see. What is going on here? What's our p-value? What happened in ours? Oh, you know what I did? I put 0.5, not 0.05. So sometimes you just have to really be careful with what you're doing because we're talking about 0.05, 5%. I actually did 50%. Okay, so here's our p-value, 0.7866, our error, our zoo statistic, and it matches what we got in here. And our sample proportion was actually 6%. Okay, so how can we interpret this? If 5% of the tigers are killed by poaching, and if we did another sample, there's a 79% chance of getting a sample proportion less than 6%. So 79% is very high. So this really high p-value really means that we are going to get that getting something less than 6%, which is what we got in our output, is 79%. Okay, so I'm going to jump ahead to the next slide, and we'll come back and talk about this one. So how do we interpret it? Because I think the back and forth is a little too much. If your p-value is less than alpha, you will reject your null and accept your alternative. If your p-value is greater than alpha, you're going to fail to reject your null and state that we do not have evidence to make a conclusion. Here, our p-value was pretty high. Our p-value was 0.79. So this is not an unusual result. So there's nothing to say, there's no reason to reject our null hypothesis. So since our p-value is greater than 0.05, we are going to fail to reject the null. Let's go to the Chinese. 90% of all restaurants fail after 1 year. So H0, P was equal to 0.9. The alternative, P is not equal to 0.9. Our sample proportion was 80%, 0.8. Our Z statistic is negative 3.271. Our p-value was 0.001. That is much smaller than 0.05. So we can reject H0. And there's a very small chance of getting a sample proportion, less than 81%. So really, it looks like the percentage of Chinese restaurants that fail is significantly different from all restaurants. Now let's take that a step further. Okay. All right, let's go back in here. Let's go to our number of successes, 87 out of 108. But let's change this. And let's say that we think less than 90% of all Chinese restaurants fail after a year. Let's compute it. Again, we have a very small p-value. So our initial hypothesis test, which said there is a difference between Chinese restaurants and the regular failure rate of restaurants. And there's also, we take it a step further and say that there is data to indicate that less than 90% of all Chinese restaurants fail after the first year. Okay, so again, if p-value is less than alpha, reject H0 and accept the alternative. If the p-value is greater than alpha, you don't reject H0, and we state that we do not have evidence to make a conclusion. So again, let's go back to the interpretation. 5% of the world population is killed by poachers. We have a p-value of 0.79. We fail to reject our null hypothesis. There's statistically insignificant evidence to support the claim that since we started educating people, less than 5% of the world population of tigers is killed. 90% of all restaurants fail after 1 year. Our p-value is small. So there is statistically significant evidence to support the claim that the percent of Chinese restaurants that fail is different from 90%. Okay. Let's go in and look at a homework problem. Okay. Historically, the percentage of residents of a certain country who support stricter gun control laws has been 53%. A recent poll of 974 people showed that 555 are in favor of stricter gun control laws. Assume the poll was given to a random sample of people. Test the claim that the proportion of those favoring stricter gun control has changed. Perform a hypothesis test using the significance level of 0.05. So what is accepted is 0.53. So H0, population that supports stricter gun control, is 0.53. So remember, H0 is a statement of equality. So right here, we can get rid of B because they have a not equal to in the H0. We can get rid of D because they have a greater than in the H0, and we can get rid of E because they have a less than in the H0. So if we look at A, the population proportion supports stricter gun controls is 0.53. The alternative is P is not equal to. I'm looking at A. C reads the same way, except that HA is P is greater than 0.53. They aren't saying that it has gotten, the proportion has gotten bigger. They're only saying test the claim that it's changed. So the answer here is A. All right. Compute the sample proportion, the standard error, SE, the z-test statistic, and the p-value. So these are straight to StatCrunch. So let's go through all the steps. Stat, proportion, one sample with summary, number of successes, 555, 974. The hypothesis that we're checking is 0.53, and the alternative is not equal to 0.53. I'm trying to split my screens a little bit. Doesn't always let me do that in StatCrunch. All right, I'm going to hit compute, and there are my numbers. Let's pull this over so it's easy to pull up. All right, so my sample proportion, 4 decimal places, 0.5698. My standard error comes right from here, 5 decimal places. And actually, you can really cheat because you can just double-click, hit Control-C, and paste it in. So 1, 2, 3, 4, 5. Yep. My Z, 2 decimal places, 2.49. And my p-value, 3 decimal places, would be 0.013. Fingers crossed. Good job. All right, so do we reject or not reject the null hypothesis? Well, if our p-value of 0.013 is less than our alpha, which was 0.05, we reject the null. So what's the correct answer? Well, what were we testing? We were testing whether or not the proportion that supports stricter gun control is 53% or 0.53, and whether there's evidence suggests that it's no longer 53%. So how do we interpret? The percentage is significantly different from 53%. Okay. Let me randomly choose one more. All right. Suppose you are testing the claim that a coin comes up tails more than half the time, 50% of the time, when the coin is spun on a hard surface. Steps 1 and 2 of the hypothesis test are given below, so we did not do that in the previous problem, and we really should have to make sure that this was legal. Suppose that you did this experiment, got 26 tails and 60 spins. Find the value of the test statistic Z and the corresponding p-value. Okay. So we're testing the claim that tails comes up more than 50% of the time. All right, so this is the proportion of tails, got 26 tails. So we assume they're random, that the sample sizes are okay. We go back stat, proportion, one sample with data. It's off the screen, but it'll be here. All right, so we had 26 out of 60. Okay. Our H0 if P is equal to 0.5. And our alternative is that it's greater than 0.5. I don't think that's happening here because this 26 is definitely less than 0.5. 26 out of 60. Compute. Here's our Z statistic, negative 1.03. P-value, 0.849. And so if we had to make a conclusion, we would state there's not evidence to suggest that the proportion of tails that come up is more than 50% because we're failing to reject the null. All right. Hopefully this helped and didn't hurt, and let me know if you have any questions. Thanks.